Unit 5, Part 1, Bonding. All right, so let's go into this. Let's talk about these things. All right, so describe an ionic bond in detail. So let's see what I know about ionic bonds. I know that maybe I should get a better pencil before I start. Some lame pencil. Okay, what I know is that it contains a metal and non-metal, or a metal and a common ion, polyatomic ion on the back of your periodic table. Oh, I should have one of those queued up as well. Okay. Polyatomic ions. Let's see. It also involves the transfer of electrons from the metal to the nonmetal. Or from the cation, and I suppose I could write this in parentheses, cation to the anion. Right? The metal is always the cation. All the things on the periodic table that are metals are plus, 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 right? Okay. Describe a covalent bond in detail. Compound that contains a nonmetal and a nonmetal. Oh, creeping off the page here. Nonmetal. Sorry I'm writing so messy. I write neater on the board. Hopefully everybody can read that. Compound that contains a nonmetal and a nonmetal and involves equal or unequal sharing of electrons. Sharing of electrons, not transfer, sharing of electrons. Right? That is a covalent compound, equal or unequal sharing, so either polar or non-polar covalent. And it is two nonmetals. The one thing, if I could get you to just recognize one thing, when you're looking at a formula, check and see if the first thing is a metal, and see if you're applying ionic rules or covalent rules. Please, 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 I'm begging you, because so many people just miss out on that small thing. What are the two types of covalent bonds? So we have polar covalent, unequal sharing of electrons, and non-polar covalent, or just covalent. Non-polar covalent, equal sharing of electrons. So it says draw diagrams representing these bonds. So this is the easier, more if you're a visual learner. So ionic. I have two atoms. One is charged positively, one is charged negatively. They're not sharing electrons, even though they're touching each other. They're not sharing electrons. If I showed you this, it would look like a big crystalline structure. But they're not sharing electrons. There's no bond line here. There's been a transfer of electrons. So whatever this cation is, it transferred electrons to this thing, and this thing became an anion. That's why they call it an ionic bond, because you have two ions, a cation and an anion. The metal becomes the cation, the nonmetal becomes the anion, or the polyatomic becomes the anion. So this is ionic. And then they say show covalent. or nonpolar covalent, and that is equal sharing of electrons. So I have an atom here and an atom here, and that is covalent. They are sharing the electron equally, so it's making a nice cloud around them equally. And then I have polar covalent, and that's where you have one element is more electronegative than the other. So let's say that this was fluorine on this side, so it's going to have a partial negative charge, partial positive charge. This thing has more, pulls the electron over, is selfish with it, has more electronegativity, so it's pulling harder. So they both own the bike, but we're going to keep the bike at the bully's house. So the bully is keeping the electron here. He's sharing it. You get to keep the electron, or some of it, but I get it most of the time. So any sharing is covalent, unequal sharing is polar covalent, and transfer is ionic. And so this one threw a wrench in the monkey works. Identify the types of bonds shown in the Lewis structures below. And how do you know the bond type? Well, here I see that this is +2, that this is +2. The only way for calcium to get +2 is to give up its 2 valence electrons. Remember, calcium has 2 valence electrons. And the only way for these chlorines to get a full 8 valence electrons is to gain 1 electron each, hence the -1 charges. So there's been a complete transfer of electrons here. So this is ionic. Whereas anywhere where you see a line bonding the two together, that is a sharing of electrons. Remember that there's 2 electrons here, and that this guy thinks he owns both of them, so that he has 8, and he has 8, and he has 8, and he has 8, and then the center carbon has 2, 4, 6, 8 as well. So it's all about sharing of electrons. So this is covalent, and this is nonpolar covalent because it obeys the rule of symmetry. It's symmetrical across both lines, so it is nonpolar covalent. Okay. Draw electron dot structures for the following. All right, so I have selenium. Y'all got to be careful about your SEs, your SIs, and your S's. I see people saying that that's silver, that is silicon, selenium. I see people putting S for silver, or for silicon, or for selenium. Make sure that you're looking at the right thing. So selenium, SE, selenium, right there. And it has 6 valence electrons, so I'm going to put 6 dots around this sucker right here. And that is the Lewis dot structure for selenium. Now, for AlBr, we have a transfer. I know that aluminum is a metal. I know that bromine is a nonmetal. I know that bromines have 7 valence electrons. Okay, so I can get rid of 1 valence electron to a bromine, so it looks like I'm going to need 2 more bromines. And drawing all these electrons in. So what I have is AlBr3. That's what it looks like, giving up 3 electrons. Transfer of electrons, so that when it's all over, I have Al3+, and I have 3 bromines that are 1- each. This is what I actually have, all these ions. That's ding, ding. If you're not with a teacher, coach, or something, blah, 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 blah. Okay. Now here I have a carbon and 4 bromines. I know that carbon is nonmetal. I know that bromines are nonmetal, so these are going to be bonded. Also know that bromine is a halogen, just like chlorine right above it. So guess what CBr4 looks like? Just like CCl4. Br, 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 Br. Can I spare the dots drawing? Can I just take less time and not draw all the dots? Okay, whatever. I'll draw all the dots. I want to be a good teacher. Okay, so that's CBr4. Sorry that this pictures are kind of impeding on each other, but that's CBr4. It looks just like CCl4. It is nonpolar covalent. So I have an ionic, a nonpolar covalent, and a single element. All right, so that's 10 minutes on the first page. Now I'm going to cut it off and go to the next.